All right, let's get right into it. If you're an HVAC engineer in Saudi Arabia, you know the drill. Getting a project signed off and getting paid can feel like navigating a maze. Well, today, we're going to turn that maze into a straight line. We're breaking down exactly what you need to do to get that approval, every single time. And let's kick things off with this piece of advice, straight from a senior engineer in the field. It's so important because it flips the script. Projects don't usually fail because of a bad design. They fail at the very end, at handover. The person who controls the final proof, the final paperwork, well, that's the person who really controls the project's success.
So that's the big question, right? What are those tripwires? It's not about being the world's best designer. It's about knowing the rules of the game. We're about to walk through the most common, the most expensive, and honestly, the most avoidable mistakes that catch even seasoned engineers off guard. Okay, first up, let's diagnose the problem. We're going to look at the top reasons projects get rejected by major clients like Aramco or the Royal Commission. If you know what they're looking for, you know what to avoid. Let's start with what I think is the #1 cause of failure: fresh air and ventilation. I know it sounds basic, but you would not believe how many projects get stopped dead in their tracks right here. And here it is, the biggest offender. Sizing your fresh air with some old rule of thumb, like basing it on the tons of refrigeration, that's an instant fail. It's a direct violation of ASHRAE 62.1 and the Saudi Building Code. There's no arguing this point. The only fix is to do it right. Use the official calculation. Now check this out. The right way to do it is actually pretty simple. It has nothing to do with cooling load. It's all about people and space. You just take the airflow rate required per person, add the rate required for the area, and that's your number. See, it's a life safety formula, not a comfort formula. So let's make this real. Imagine a typical office, 10 people, 100 square meters. You run the numbers, and you get 130 liters per second of fresh air. That's it. That's the exact number an inspector is going to look for in your paperwork, and then they're going to walk out to the site with their meter and check it. Okay, this next one is a huge health violation. If you connect a toilet's exhaust into the main return air duct, you're literally pumping contaminated air all through the building. It is absolutely forbidden. The only way to fix it is with a totally separate exhaust fan, and you better believe they're going to pull out a smoke pencil to make sure it's working. So, let's just recap these core air quality rules. Every space has a mandatory minimum for outdoor air. You can't guess. Your fresh air intakes have to be far away from any exhaust outlets, at least 3 meters. Your filters have a minimum rating. MERV 8 is the baseline. And places like bathrooms and kitchens have specific, non-negotiable exhaust rates. Get these right, and you're already way ahead of the game. All right, next section. Let's talk about efficiency and safety. With Saudi's Vision 2030, energy consumption is under a massive microscope. And with new refrigerants, safety is too. These are not areas you can afford to overlook. You know, the days of simple on or off systems are pretty much over. If you have big pumps or air handling units just running at 100% speed all the time, you're toast. It's a violation of energy codes like ASHRAE 90.1. The fix? You need to install a variable frequency drive, a VFD, which lets the motor intelligently ramp its speed up and down to match the actual demand. And this chart shows you exactly why this is a big deal. The energy savings aren't just, a little bit here and there. They are huge. A VFD can slash the energy use of a motor, especially because most of the time, systems are running at partial load. This visual right here is why an energy auditor will fail a system without a VFD on the spot. Now for a critical safety point. VRF systems are everywhere, but they use a lot of refrigerant. If you get a leak in a small enclosed room, that's a serious hazard. That's why ASHRAE 15 and 34 require a dedicated gas detector, and it has to be wired to automatically turn on an emergency exhaust fan. An inspector will physically test that connection. No excuses. Okay, let's move on to comfort and critical spaces. This is about making sure the system not only works, but provides the right environment for people, and in the case of hospitals, a safe environment for patients. You ever see water dripping from ductwork? That's not just a mess to clean up. It's a giant red flag that your project has a problem. In the high humidity of the Gulf, it's a clear sign that your insulation isn't thick enough, or more likely, your vapor barrier isn't perfectly sealed. This is a visual failure of ASHRAE 55 comfort standards. Now, take that concept into a hospital, and suddenly it's a life or death situation. Getting the room pressure wrong can literally spread diseases. An isolation room has to be under negative pressure to keep germs in, while an operating room must be positive to keep germs out. I guarantee you, this is one of the most intense tests during any hospital handover.
In this table right here, this is your cheat sheet from ASHRAE 170. These numbers are set in stone. Isolation room, negative pressure, at least 12 air changes an hour. Operating room, positive pressure, and at least 20 air changes. You don't just have to design for these numbers, you have to prove you're hitting them. Which brings us to our last and, honestly, our most important section. Look, you can build the most perfect HVAC system in the world, but if you can't prove it works with the right documents, you will not pass. This is all about getting that final signature. Let me tell you, the single biggest reason projects get stuck at the finish line is this right here: showing up to a handover meeting without a formal testing, adjusting, and balancing report. To a client like Aramco, a system without a tab report isn't a finished system. It's an automatic, come back when you have it, rejection. So what is this TABE process? It's actually really simple in concept. A specialized team comes in and measures the actual airflow coming out of every single vent. Then, they tweak the dampers and the ducts until the real-world airflow matches your design drawings, usually within about 10%. All that data gets compiled into a big report that proves your system does what you said it would do. And remember, your work isn't over when the system is turned on. You're not just leaving, you're handing over a valuable asset. That means you have to provide the complete operations and maintenance manuals, a detailed schedule for future preventative maintenance, and proof that you've trained the building staff on how to use it. No plan, no handover. And so, this is it. This is the master checklist. This is your passport to getting paid. You need the final calculations for fresh air and cooling load, the duct leakage test results, the final tab report. For special cases, you need those hospital pressure tests and VRF gas reports. And to wrap it all up, the energy model, the complete O&M plan, and of course, the final as-built drawings. Have this binder ready to go, and you are in total control. So let's be crystal clear. The engineer who understands this list, who controls this paperwork, that's the engineer who gets projects approved without headaches, who builds an amazing reputation, and who makes sure the company gets paid on time. Mastering these documents isn't just paperwork. It's mastering your own success. So, we've walked through the common failures and the exact corrections. We've given you the final checklist. Everything we've covered, that's the master key to unlocking project acceptance. The only question left is, are you ready to use it and take control of your projects?